Hello, and welcome to our first video for our linear relationships unit. So we just finished linear expressions, where you guys learned to solve linear equations. This unit is similar in that we're going to continue with that linear pattern, only now we're going to look at graphs and tables and more of the standard slope-intercept form equation in that linear material. So make sure you put your name on your packet and what period you have your math class, and we're going to start with just an introduction, okay? And actually I'm going to have you skip down to the bottom of your first sheet. So find this first sheet that starts with slope and then skip down to the bottom where it has y equals rise over run x plus b. And we're going to talk about, this is just the general form of a slope-intercept form equation, okay? And we're going to talk about what each thing means, okay? We're going to start with the main two things. These things you'll see all the time. That's the rise over the run. The rise over the run is called our slope, okay? So let's call that our slope, and we'll talk about slope by itself in a little bit. We also, you might see it called M, okay, so sometimes it's called M. We're going to talk about it as rise over run because there's really two parts to the slope. There's the amount we go up or down and the amount we go over, okay. This is our constant rate of change. And we always multiply it by x, okay? So whatever x is, we multiply our slope times that, okay? And we might add to this throughout the video, but that's a big one, the slope, the m, the constant rate of change, okay? B is the y-intercept. And the y-intercept is also known as a starting value, or on a graph it's going to be where the line crosses the y-axis. So where the line crosses the y-axis. On a table it's going to be where x is 0, and here if x is 0, y is the y-intercept. So when x is 0, y is the y-intercept. So that would be our B, okay? Those are the two most important parts of this type of linear equation. The x and the y, those are variables, and we know from our first unit that variables, like their name, they vary. They can be lots of different numbers, where this and this are going to be one number. For our variables, we're going to have x is the independent variable. It is multiplied by the slope, but it is not part of the slope. So it's not actually the slope. The slope is just the rise and the run. The x is its own variable. Okay, so if x were 2, we take 2 times whatever the slope is. Okay, y then is the dependent variable. And that means, like in a real world situation, if you're selling cups and making money, the amount of money you make depends on the amount of cups you sell. So your cups would be the independent variable, and the money you make would be the dependent variable. It's often called the answer, just because it's by itself. Okay. Another word for x is the coefficient. And that's just the mathematical term. We might have talked about it a little bit in solving equations. okay, and b would also be our constant. But we're going to talk about b as the y-intercept and rise over run as the slope, and those are the two important ones. So let's dig a little deeper into slope. If you go up to the top of your note sheet now, slope, the definition for this is a number that describes both the direction and the steepness of a line, okay? And why don't you make a note there also that we call it the constant rate of change, and we call it the rise over the run, and we call it m. Okay, so we call slope a lot of things, so you can pause the video and take those notes down if you want. There are 4 different kinds of slope. The first is a positive slope. This is where we rise up and run right. So we rise up and we run right. That makes a positive slope. So this could be anything from just 2, which would equal 2 over 1 if we're talking about rise over and run. It could be 5 over 4. It could be 6 over 7. It could be any fraction that's positive, where both numbers are positive. A negative slope is where we rise down and we run right. Now, notice we always run right. If we run to the left, we call that going backwards, and we'll do the opposite. So here, if we run to the left, we go down. Here, if we run to the left, we go up. But with a negative slope, we rise down and we run right. So this would be if we had negative 2. Or that would be negative 2 over 1. Sometimes in a fraction you'll see the negative out in front, so negative 5 over 4. And if you ever see the fraction on the bottom, so like 6 over negative 7, we're going to want to change that so that the negative is either out in front or on the top, because we change whether we're going up or down. We don't change whether we're going right or left. We always run right. Run right will be something you remember after this unit. And then these two are kind of extra bonus ones. Zero slope is where we rise nowhere. So we don't rise. There's no rise. But we still run right. We always run right. Okay, so there's no rise. We always run right. This is going to be an equation without a slope. So it's just going to be like the equation y equals 2 or the equation y equals negative 5, where we just have a constant. So y is always the same thing. So we're rising nothing and running right, or rising nothing and running left. Okay, and then finally, the undefined slope. We rise up or down and down, but we don't have a run. So there's no run. So this is going to be an equation where x is always something. So x equals 3 or x equals negative 6. Something like that, where x is just always the same thing and y changes the whole time. Okay, so those are the 4 different types of slope. Let's talk a little bit more about slope. There's slope determines how steep a line is. So the greater the number, the greater the steepness. So I'm going to change or cut this box in half, and let's talk about positives. So if we have positive, a slope of 3 would mean we go up 3 and over 1. So that's going to be a pretty steep slope. Okay? A slope of 1/2 would mean we go up. For every 1 we go up, we go over 2. So that's going to be less steep, right? A slope of, let's see, 5/4. Well, 5/4 is close to, well, that's 1 and 1/4, right? So it's going to be about in the between these two. So if I go up, for every 5 I go up, so let's say 1, 2, 3, 4, 5, I'm going to go over 1, 2, 3, 4. So that slope is going to be in between. This is a really steep slope. This is a more shallow slope, and this is a very shallow slope. Something that would be less than this. What can you think of that would be less than this? 1/4, 1/8, 2/15, something like that, where our denominator is going to get bigger and bigger. So we have a smaller number. Now it gets a little trickier when we go negative. But really, if we talk about the same 3 slopes and just make them negative, this would be -3/1. So we would go down 3, 1, 2, 3, and over 1. So I still have the same steepness. I'm just going the opposite direction. This would be down 1/2. So if I start here, I go down 1/2. Still the same steepness, just going the opposite direction. And then here, if I go down 5/4, again, it's still going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, about the same steepness. I'm just going the opposite direction. Okay, so the greater the number, the greater the steepness. And Khan will have some problems that will ask you to write or graph a line that's negative and less than, or negative and greater than, and we'll talk about that later too. Parallel lines, I think you guys all know what parallel lines are. They have the same slope. So parallel lines are lines that never meet. So if I draw a few parallel lines here, and let me actually use the line tool. If I draw 2 parallel lines, and to make sure they're parallel, let me just make a copy of this one. So those are parallel. They're never going to meet. And what makes them parallel is the fact that if I take 2 points on these lines, they will have the same slope. And a lot of times we use these triangles to talk about slope. So this triangle should be the exact same as this triangle. Okay, so if let's say our triangles, we go up 1/3, this is also up 1/3. Okay, so both of these lines have the same slope of 1/3. That equals their rise over their run. Okay, and we could have the same thing if they're going down. So let's say these two. We could have the same thing if the line's going down. Let's make a steeper line, and we'll copy that. And let's say this line, these lines go over 1, down 4. So 1/4, over 1, down 4. That's the slope of these two. So that would be -4/1. Okay, because we do our rise, we rise down, we run 1. That's their rise over run, and they're the same thing. So if they're parallel, they'll have the same slope. Perpendicular, which you might not be as familiar with perpendicular. So if I have a line that's perpendicular to this one, so we knew this line had 1/3, right? The slope of this line was up 1/3. So m equals 1/3. If I want a line that crosses that line at a 90-degree angle, that's what perpendicular means, I would need a line that goes down 3 and over 1. So if they cross at a 90-degree angle, it looks like there, we'll make a 90-degree angle there. Then if this truly is a 90-degree angle, this line would go down 3 over 1. So it would have the exact opposite slope, down 3 over 1. So for this line, m would be negative 3 over 1. And reciprocal just means in a fraction you flip the fraction. So here the reciprocal of 1/3 is negative 3 over 1. Here the reciprocal of negative 4 over 1 would be positive 1/4. Okay? Over here the reciprocal of 5/4 would be negative 4/5. So perpendicular lines have opposite slopes. All right, then let's just review quick. We have y equals rise over run times x plus b. Okay, now again, here we can have positive slopes that have positive and positive, or the more common or most common are positive and negative. So we could have negative 5/4. Now, but remember that negative always goes with either we rise up or we rise down. Same thing here. We could have a negative b. Okay, so that could be where if we have a line here, the line crosses the y-axis in the negative y value. So b could be positive or negative. So you might want to put a subtraction sign up there as well. And that is our first video. Next video, you're going to learn how to graph one of these equations.